Hi, so this flashcard deck was compiled to assist you with standalone questions dealing with the topic of acids and bases, and this is deck 1 for this topic. There'll be some more. Write the formula for pKa in terms of Ka. So what is pKa in terms of Ka, the acid dissociation constant? pKa equals the negative log base 10 of Ka. So two things you have to keep in mind is that it's a negative log, don't forget the negative, and it's base 10. So you're asking the question, for this number, what power do you have to raise 10 to in order to get the magnitude or the Ka? What is the value for Kw? What is the value for Kw? And the name for this is the ion product of water. That would be 10 to the negative 14th power, okay? So Kw is derived, well, actually there's going to be more on this, so if you're not totally clear on what Kw is, or if you don't completely remember, just, go through the entire deck or Google it. A species that has a Ka that is much, much greater than 1, that means the value for the Ka is really large, is a strong or weak acid. So what is it? Is it a strong acid or is it a weak acid? It's going to be a strong acid. So if the acid dissociation constant, and that makes sense, if it dissociates a lot and you have a large Ka, it would make sense that it's strong. Yeah, so that makes sense. If you have a large Ka, that means it's dissociating a lot, because remember the Ka is the acid dissociation constant. And remember that NH3, not NH4, is a strong you have in solution. Ammonia is a strong or weak base. What is it? This is going to be a weak base, and this is actually something that you should definitely memorize. So memorize the fact that ammonia sorry for the janky writing. So yeah, memorize that ammonia is a weak base, okay? Ammonium, now this is NH4, reacts with water to form blank. And it's specifically, ammonium is NH4 positive. So what does it react with water to form? Now ammonia, NH3, is your weak base, but ammonium is going to be your acid. It's a relatively strong acid. So it reacts with water to form the hydronium ion, which is this H3O plus. Okay, so NH4 plus, aqueous plus H2O, here goes your water, is going to give you ammonia with it ending in an A. And ammonia has two two unpaired electrons. Remember, nitrogen itself has 5 valence electrons. This has 5 valence electrons. And the proton usurped from ammonia is going to get attached to water to form your hydronium ion or cation. Write the formula for pH in terms of the concentration of hydronium. Okay, remember the concentration of hydronium is also a surrogate for the concentration of protons in solution. And just remember that a hydrogen cation is often referred to as a proton because remember, hydrogen doesn't have any nitrogens in its nucleus. You might not even know that, but just, you just learn. So pH, again, here goes that negative log base 10 of the hydronium ion concentration. And notice that the formula for pKa is the same thing as pH. The only thing that differs is what you're looking at, the molecule, the concentration that you're trying to find the exponent for. Strong bases ionize almost irreversibly, so their products are strong or weak conjugate acids. So the conjugate acids of strong bases, are they strong or weak? That would be weak, because if something proceeds to reaction, really in the forward direction, there's no reverse, that means it's not going to go back. So, the conjugate acid isn't going to give up that proton in order to become a base again.